A cam, what is meant by cam? A cam is a rotating machine element used for transmitting desired motion to a follower by direct contact. By direct contact, a cam may be a reciprocating motion or rotating or oscillating motion, whereas for the follower maybe reciprocating motion or oscillating motions, right? A cam, it has three motions, maybe reciprocating, rotating or oscillating, whereas for a follower it has only two motions, one is reciprocating motion or oscillating motion, right? A cam and follower have a line contact, right, because it comes under a higher pair. Already we discussed about lower pair and higher pair in first unit. So this cam and follower comes under the higher pair because both are the contacting point at line contact, right? And now let us discuss about three necessary elements of the cam. See, right, one is the cam, follower and frame, right? These three things are very important in cam. These are called as three necessary elements, right? So cam is acting as a driving member and follower is acting as a driven member. That's why we are called as a follower, and the follower follows the cam motions, right? That's why we are called as follower. And frame, it supports the cam and it gives, it guides the follower, right? And it's a very simple comparison between cam and linkage mechanisms. Cam it occupies only little space, whereas for linkage mechanism it occupies more space, and it's very easy to obtain dynamic balancing for cam, whereas for linkage mechanism lot of analysis are there in order to achieve the dynamic balancing, right? So the production of cam is expensive process, whereas for manufacturing of linkage it's very less expensive, right? Moreover, for cam the more vibration possibilities are there, whereas for linkage mechanism it's quite in operations. Moreover, the cam is subjected to surface wear and fatigue, right? Whereas for linkage mechanism joint wear is non-critical and quite in operations, right? So this is a simple comparison between cam and linkage mechanisms. And classification of cams. Basically the cam is divided into 6 major category. So one is radial cam, wedge cam, and cylindrical cam, conical cam, and globoidal cam, and end or face cam. See the picture, this is the radial cam, right? And this is the wedge or flat cam, and this is cylindrical cam, conical cam, globoidal, and end or face cam, right? See, in radial cam, the follower reciprocates in a plane perpendicular to the axis of the cam. This is the axis which is perpendicular to the cam, and this follower reciprocates in a plane perpendicular to the axis of the cam, right? Whereas for this radial cam are also known as disc cam or plate cam, right? Whereas for wedge cam, it's very interesting. The wedge cam has wedge shape. See the shape, it seems like the wedge, right? Which imparts that translatory motion to the follower, right? And for cylindrical cam, a cylinder which has circumferential contour cut in the surface rotates about its axis. The follower rides at the groove. The follower rides at the groove cut on the periphery of the cylinder, right? And these things are not important. Switch over to next. And yes, classification of followers. So classification of followers. In the last slide we discussed about classification of cams, whereas for here the classification of followers are there. Classification of follower majorly divided into three. One is according to the shape of the follower shape and motion of the follower and the path of motion of the follower, right? So first one is according to the follower shape and according to the motion of the follower and according to the path of the motion of the follower, right? So according to the follower shape, four different follower shapes are there. One is knife edge follower, roller follower, flat follower, and spherical follower, right, or spherical faced follower. Here according to the motion of the follower, two categories are there. One is reciprocating follower, another one is oscillating follower. And according to the path of the motion, one is radial follower and another one is offset follower, right? So let us discuss one by one what is what. Now according to the follower shape, the first one is knife edge follower. Knife edge follower, which means when contacting it of the follower has a sharp knife edge. See here the contacting end of the follower, it seems the knife edge. So that's why this is called that's why this category is called as knife edge follower, whereas for here it is rarely used because excessive wear due to small area of contact. Here excessive wear due to small area of contact. See here the contact between the follower and cam is just like the sharp edge, right? So that's why excessive wear due to small area of contact, right? So next one is the roller follower. When the contacting end of the follower is roller, see here the follower end is roller and the cam it rotates, the contacting end which is the roller, so it is called as a roller follower, right? So here the wear rate is considerably reduced. Why? You know that the rolling motion between the contact surfaces, right? So that's why the wear rate is considerably reduced in this particular case. Whereas for flat follower, third category is flat follower. For flat follower, when the contacting end of the follower is perfectly flat faced, see here the end of the follower is perfectly flat, right? In this flat follower, the follower causes high surface stress, right? Moreover, these flat faced followers are commonly used in automobile engines, whereas last category is spherical faced follower, right? Spherical faced follower, the end of the end of the contacting follower, it seems the spherical head. Why? You know that in order to minimize the surface stress produced in the flat faced follower, in previous case it's a flat faced follower. See here high surface stresses are there. In order to reduce these high stress surface stresses, here they machined to the spherical shape, right? So here the surface stresses are reduced, right? And the next category is according to the motion of the follower. Two type of motions are there. One is reciprocating motion, another one is oscillating motion, and this is reciprocating motion. When the follower reciprocates in a guides as the cam rotates uniformly, right? See here the follower is reciprocates up and down, whereas here the follower oscillates, right? Front and back. When the uniform velocity motion of the cam is covered into predetermined oscillatory motion of the follower, right? So this is called as the rotating follower or the oscillating follower, right? And last category, according to the path of the motion, here radial follower and offset follower. This is without offset. See the axis of the follower. Axis of the follower is in line with the cam axis. See the axis of the follower in line with cam axis. That's why this is inline follower. And here, see this is offset. The axis of the follower is the here and the cam axis here. The distance between this, which is called as the offset, right? See the axis of the follower is offset with the cam axis. So that's called as this is offset follower, right? So see some examples of rotary cams in operations. See here the cams are used to control the movement of the engine valves. Here we know that see cams are used in pumps, and we know that already for IC engines we are using cams in order to open and closing of inlet and outlet valves. Already we know about that, and this is some of the applications of cams in toys. See how the cams are used here. See, and this is the cam hammer designed around 1497 by Leonardo da Vinci. This hammer converts the rotary motion into oscillating motion.